Oh, good. I hate doing talks to interpretive dance. Okay, there are a number of established reasons why to incorporate citizen science into your missions and projects. Some of these include helping to process large amounts of data, as were exemplified by SETI at home and Stardust at home, taking advantage of special circumstances such as the reentry of the Stardust spacecraft and the observation campaign for the L-Cross mission. Remember, negative results are interesting. Providing mission operations support. Okay, that one sounds scary, but hang with me. We'll talk about that a little bit. Provide some good examples. And providing useful background science data. Again, we'll have some good examples for that. But beyond these standard justifications for citizen science, there is another one that is becoming of growing importance, especially now in these times of contracting budgets and political spin when science all too often comes out sounding like a four-letter word. Basically, we are in a fight for the hearts and minds of the public. And one of the great tools that we have at our disposal is to actually involve the public in our science, in our missions. As they become a part of their mission, as this mission becomes theirs, they have a personal stake in it. Their interest grows, and they can become our greatest ambassadors and advocates. And in building this cadre of advocates, you don't have to start from the ground up. They're already out there. There are some wonderful programs out there. ASP and JPL combined together to run the Solar System Ambassadors Program and the Night Sky Network. This is an army of volunteers and an army of amateur astronomy clubs. They have drunk the Kool-Aid. They want to tell your story. They are hungry for your information so they can go out there and tell the public about it. This is a great resource for you. Another great example, you've just heard about Moon Mappers, another program, MoonZoo, where the public, people from grade school all the way to retirement homes, can help interpret the data coming back from LRO. One of the great things that I really loved hearing yesterday in one of the talks was a discussion. We had a wonderful talk about the lunar pits. And there's a few examples of these known, and we would like to find more. And it was brought out that, wow, Moon Mappers would be an outstanding tool to help find more examples of these fascinating objects. This is where tools like these can be used. Now, the boundary between citizen science and education is not a clear-cut one. And as you start getting toward education, you get into this realm of participatory exploration. And one great example I will point out to you is Gabbard, the Goldstone Apple Valley Radio Telescope. It's operated by the Lewis Center for Educational Research down in Southern California, again in partnership with Goldstone. And this is where students across the country and around the world can take control remotely of 34-meter dishes out at the Goldstone Deep Space Tracking Complex and use these dishes to do radio astronomy, but also to track spacecraft. That is their heritage. We used this in the L-Cross mission. We had over 1,700 students tracking and monitoring the health and status of our spacecraft. That was of great value to us because DSM time is pricey. It costs a lot. These students were listening at times when we could not listen. We got extra value for this in the mission. We got extra DSM coverage, and the students had the opportunity to actually participate in a lunar mission. We're doing this again with the LADI mission. One of the more spectacular ways that amateurs are contributing now in lunar science is through their imaging. Through the process of image stacking, deconvolution, and wavelet processing, they are able to achieve resolutions that until recently could only be achieved from spacecraft. It's really remarkable what they are doing. And one of the great benefits of this is they can retrieve images under any angle of solar illumination. Take a look at Lunar Picture of the Day and look at the number of instances where new features are being revealed by the proper angles of solar illumination as revealed in amateur images. This picture right here was part of the campaign for LCROSS in actually selecting our impact site. And the amateurs, through their imaging, helped us understand the shadowing conditions at various craters here. This was of great benefit to the mission. Another great example of professional and amateur collaboration is in this program of looking for meteoroid impacts on the moon. NASA's Meteoroid Environment Office is very interested in how often, the rates and the changes in rates of meteoroid impacts on the moon. And it turns out these flashes from meteoroid impacts are optimally recorded in telescopes of 8 inches to 14 inches of aperture, just what amateur astronomers have. In the LADEE mission, we are very, very interested in this program because what we would love to do is have as many eyes as possible on the moon during our mission recording these impact flashes so that we can correlate impacts on the moon with any changes that our instruments see in the structure and composition of the lunar atmosphere. That's great if you happen to have an 8 to 14 inch telescope, but a lot of people out there do not have that kind of equipment, but they'd still like to participate, and they can, because the vast majority of lunar impactors are really small, on the order of 1 micron, way too small to create a visible flash from here on Earth. But because even small pieces of debris become evident in our sky as meteors, what we would love to have is people out during the LADEE mission counting meteors, looking at changes in flux from night by night. Again, we can make inferences as to what's happening on the moon's surface. The great thing is anyone can participate. You don't need a telescope, you don't need binoculars. I do recommend a reclining lawn chair. But it's easy to do. We have the Girl Scouts working on this. And just as the case with everything else out there today, there's even an app for that. So NASA's Meteoroid Environment Office has come out with Meteor Counter. You take your smartphone, you go out under the sky, it knows where you are, it knows what time it is. You start tapping for meteors, and then it'll download all that information or upload all that information to the Meteoroid Environment Office. So even the most inexperienced can participate. But at the other end of the spectrum, there are amateur observers out there who are doing fantastic, fantastic work. People like Maurice Collins in New Zealand and Raffaele Elena in Italy, more close to home, Richard Evans and Jim Mosher. These people are creating tools and using existing tools such as the ACT-REACT Quick Map to be able to analyze and interpret both amateur acquired data and data from spacecraft. They are finding new features that have previously been unrecognized. They are producing real professional quality data. It is published in peer-reviewed journals. It is presented at LPSC, and I hope to see some of it presented here at our conference. This is exciting stuff. You are being confronted with this giant haystack, ever-growing haystack of data coming from our current spacecraft. And there's a lot of beautiful needles in that haystack. You've got to find them. These people can help you find them. They can comb through this. They are a resource to find these features that then your theories can investigate further. They are a resource for you. Where do you find this resource? Well, fortunately, they travel in herds. They actually form groups. And these groups even have journals. And you can use these journals as means to communicate with them and express your needs and start forming these collaborations. As you encounter this growing haystack of data from our spacecraft, as you have more and more data to comb through, keep in mind that you are in a position, as lunar scientists, you are in a position that the astronomy community has been in for a couple of centuries now. And one of the things that the astronomy community has done is formed a very, very effective partnership with the amateur community. An example is just over a year ago, the AAVSO, the American Association of Variable Star Observers, celebrated their 100th anniversary with the 20 millionth observation of a variable star. In the 1800s, the Astronomical Society of the Pacific was formed as a collaboration between the amateur and professional astronomy communities. As lunar scientists, we have a lot to learn from the experience of our colleagues in astronomy. They are, after all, the practitioner of the world's second oldest profession. Here at the Lunar Science Institute, we are committed to the furthering of citizen science, and we hope that you will join us in this venture. This is a way to further lunar science and also to help capture the hearts and minds of the public. Thank you very much.
Can you see why Yvonne and I are so happy to have Brian on our staff? We're so proud of the work that he does and the work that we support with Pamela. It's just incredibly important to get the public engaged. Maybe time for one question. Joe in the back.
Thanks. Very nice. I think one of the very interesting aspects of the AAVSO is, of course, it allows these very long time records. I mean, literally one can start looking at how stars have changed over a century. And I'm wondering, is there a similar approach that could be used in lunar science of, are there sufficient records that one can start looking at the moon, start thinking about the moon on time scale of decades?
That type of thing is probably evolving now as we speak. There's a long record of visual observations. Transient lunar phenomenon have been something that have been recorded and sketched for quite a while, but that doesn't compare with having an actual video. Now with the high-quality astronomical video cameras being easily available for $300, this type of thing, we can start developing these archives. And so this is the type of thing that right now the Meteoroid Environment Office and ALPO are working on together so that we can have this kind of history of these events. We now know that the moon is, in fact, not this dead place. It's a very active place. And so it certainly warrants this type of archiving of information.
And Joe, one thing to add to that as well is that we at NLSI are supporting the Lunar Orbiter image reconstruction project, and that is bringing data contained on these very old tapes to a new modern standard and improving the resolution and dynamic range of these very old images that were taken in the 60s. The idea being comparing these with the LROC images and taking a look at changes that have happened. And I'm sure that in the future we'll be working with moon mappers, perhaps Moonzoo and others on this.
And I think part of my question was, though, are there amateurs that have images or pictures, sitting in a drawer someplace from 1970 that should be resurrected or somehow archived?
Again, probably one of the good sources would be the Association of Lunar and Planetary Observers, as well as the British Astronomical Association. Those would be where I think the two main repositories for that would be right now. There's nothing organized at this point.